Geometry lesson 1-7, looking at a coordinate plane and the geometric figures that are on it. Find the area and the perimeter, which is the distance around a triangle defined by these 3 points. -2, 2, 3, -1, and -2, -4. In order for me to find the area or the perimeter, I need to know some of the dimensions of the triangle itself. So first of all, I'm going to take the coordinate plane and I'm going to graph it. So -2, 2 is going to be right here. And 3, -1 is right here. And -2, -4, 1, 2, 3, 4 is right here. So now we are defined this triangle as such. This particular triangle, if I take it and I move it, this is the triangle right here. Anytime you want to know the area is always 1/2 the base times the height. Now this particular triangle, you can actually find the base and the height very easily. The height of the triangle could be right here. You may not see that because if I turn it, now it's a little easier to see. There's the height, and then that would be the base, which is easy to count on this coordinate plane. I can count the height right in here as 1, 2, 3, 4, 5. There are 5 units right there for the height, which means h equals 5. And you can also calculate the base. The base is 1, 2, 3, 4, 5, 6. This is 6, which means b equals 6. Those 2 pieces of information are going to allow me to find the area of that triangle very easily. A equals 1/2 the base of 6 times the height of 5, which means 6 times 5 is 30. Half of 30 is 15. I don't know any units, so I'm going to say units squared. Now I already know 1 side length. What I don't know are the other 2 side lengths. I need to determine those. The best way to determine those is by using the distance formula. Now this is h here, and j here, and k here. I need to find the distance from h to j, and I need to find the distance from k to j. Once I have those 2 distances, I can add it to the 6, and I'll have the perimeter of the whole shape. So, set it up. I know there's subtraction squared plus subtraction squared, and I'm going to substitute in my x values. I'm going from h to j. So for h to j, I want to put the x's -2 and 3. Oops, put it in the wrong spot. -2 and 3. Over here go the y's, which is 2 and -1. You can now watch my signs, plus negative, plus positive, and I end up with -5 squared plus 3 squared, which becomes 25 plus 9, or square root of 34. So that's the exact value of this expression, which is the length from h to j. I do the same thing, set it up, subtraction squared plus, subtraction squared plus. But now I want from k to j, so 3 and -2 will go here because those are the x values, and -1 and -4 are the y values. I watch my signs, plus positive, and I end up with 5 squared plus 3 squared, which is looking eerily familiar to this over here. 25 plus 9 makes the square root of 34. Now you may say to yourself, well, duh, it has to be. That doesn't necessarily have to be. This is an isosceles triangle now, according to what we've decided. I didn't know that. It could have been a scalene triangle where all three sides were a different length. I could still calculate the height and the base the way I did up there. So I have to put all these together to find the perimeter. The perimeter is going to be the square root of 34 plus the square root of 34 plus 6. Alright, those are my values. Now you can simplify this. I think the square root of 34 and the square root of 34, if we think about it, are there any perfect squares? Well, perfect squares are 4. 4 doesn't go into 34. Perfect squares are 9. Well, 9 doesn't go into 34. Perfect squares are 16. Close, but 16 won't go in either. 25, no, and 36. Okay, so no perfect squares are going into 34. Therefore, the perimeter, I'm going to simplify it as 2 square roots of 34 plus 6 units. And it's not squared because it's perimeter. These units are squared because it's area. So the perimeter, the reason why it's 2 of them, there are 2 of them here being added together. If this was a 5 and that was a 5, you could say 2 5s, which would be 10. 2 of 30 square roots of 34. Alright, we have a problem-solving plan that we can use. It's on page 53, but I'm going to discuss it here. The very first thing you want to do is write a verbal model or draw a sketch. Drawing a sketch is extremely helpful, especially in geometry. There's a lot of words, and it helps to put things down as a picture. Then you can manipulate the picture, draw on it, do whatever you need to do to figure it out. The verbal model is anything you're using words for. Even if you were to say something like volume equals length times width times height, that's in words. You can then substitute values that you know, which is what number 2 is. Label any known and unknown facts. Anything you know, you substitute that value in. Anything you don't know, that becomes an unknown. It becomes a variable that you stick in there. You leave the variable in. Step 3. Choose any related definitions, theorems, or formulas. If you're dealing with a volume problem, try to find the proper volume formula. If you're dealing with an area problem, try to find the proper area formula. If it's a shape that you know, if it's anything that has to do with any properties, you can use those to determine what you want to have as far as your answer. Step number 4, reason logically. Always consider your answer and say, does it make sense? Because I've seen a lot of people get answers that if they actually thought about it, they'd go, that just doesn't seem right. It seems too big, seems too small. All right? So check that out as far as you go. Come to a conclusion and check your answer. If you decide that your answer is not right, then go back up and make sure you've done something correctly. Maybe you didn't choose the right definition, theorem, or formula. Maybe you ought to tweak that. Maybe you labeled something incorrectly. Maybe there's something wrong with your drawing. But go back and check to make sure you've actually done it correctly. Our last example. A picture is 8 inches wide and 10 inches tall. The matting, which goes around the picture, is 2 inches wide all the way around. Our job is to try to find the area of the mat. If we think about our problem-solving plan, writing a verbal model and or drawing a sketch probably is pretty important here because there's so many words in this problem, we really don't know what's going on. So I've gone ahead and I've drawn it for you. The blue rectangle represents the picture, and the brown rectangle around it is the matting. I have the picture. Maybe now we think about labeling any unknown and known facts. So the picture is 8 inches wide and 10 inches tall. The matting is 2 inches wide. That means from here to here is 2 inches. And from here to here is 2 inches. And here to here is 2 inches. And here to here is 2 inches. Which means you should be able to figure out how wide or how long or tall this actual amount is. The 2 inches here plus the 10 plus the other 2 make a grand total of 14 inches. And here, the 2 plus the 8 plus the 2 makes 12 inches. If you want to find the area of the matting, there's multiple ways you could do it. I think it would take a while to make a bunch of rectangles, but you could. You could try to figure out this rectangle, and this rectangle, and this rectangle, and this rectangle, and you can put them together. That is certainly a viable way. Because there's typically more than one way to do these kind of problems. But I think it's probably easier if you find the area of the entire shape, and then find the area of this part and subtract it. Take it away like a donut hole. If you take this away, you're left with the outside rim, like a donut, and you'll have your area. So the area of the big rectangle is going to equal length times width, which is 12 times 14. The area of the small blue rectangle is equal to 8 by 10. If you do 12 times 14, what I do is I think about 14 times 10, which is 140, and then 14 times the 2, which is 28, should give me 168. 168 inches squared is the area, and this is 80 square inches. Now it's just a relative matter of subtracting the 80 from the 168. 168 minus 80 equals 86 inches squared. It's kind of crazy to think about it, but there's actually more area in matting than there is in the actual picture. There's 80 inches of picture, square inches of picture. There's 86 square inches of matting. Does that make sense? Well, I think so, because you've got this part here and this part here, which are the same width as, probably fill in like that. And then you've got this chunk here and this chunk here, which you can put in here, which would cover up some of that. So it's starting to look like it's more than the area that's inside the picture. So I think it's a reasonable answer. So our conclusion, that in fact this is the area of the tagboard, or the matting, I'm sorry.